Welcome to the AI Applied podcast. I'm your host, Jaden Schaefer. Each week, I cover breaking AI news, tools, and interview experts giving you actionable tips on applying AI into your career, job, workflows, and life. Make sure that you go to aibox.ai, link in the show notes, to join the waitlist for our new AI platform. We're going to be launching an incredible platform that allows you to build anything you want with workflows in AI. So you're able to chain together ChatGPT and image generators and audio generators to make really powerful apps for your organization, or you can host them on our marketplace and actually generate royalties from them. So make sure to go to aibox.ai and join the waitlist. In addition, if you like the podcast, if you could do me a massive favor and please leave us a review on Apple or Spotify or wherever you listen to your podcast. This helps me be able to get better guests on here as they check the reviews to see how you guys are liking it. So if you could please do that, I would really appreciate it. Google has recently unveiled some new quantum computing capabilities that have a big impact on AI. So today on the podcast, we're going to be diving into what Google is officially announcing right here. Also, we're going to talk a little bit about the past because they do have a little controversy with achieving what they call quote unquote quantum supremacy. They got called out. We're going to talk about that. We'll jump into it. And then we're going to talk about the implications for AI and where we see quantum computing making the biggest change in AI into the future. So without further ado, let's jump into it. The first thing I want to cover on the podcast today is kind of the history of what is going on here for a little bit of context. So back in 2019, Google claimed that they achieved quantum supremacy, which essentially kind of comes from, it's like a funny, obviously industry jargony term, but it comes from a blog post written by John Preskill back in 2012, where he essentially described quantum supremacy as a point where quantum computers can do things that classical computers can't. And while Google back in 2019, they built a quantum computer with 53 qubits of quantum computer, and they said that it could perform a calculation in 200 seconds that would take classical computers 10,000 years. Now, they said, okay, we've achieved quantum supremacy with that, but some of their competitors over at IBM, who are also working on quantum computers, kind of called them out and said, this doesn't count because technically the phrase quantum supremacy refers to being able to do something a classical computer can't, and if the calculation they did could be done by a classical computer in 10,000 years, then technically a classical computer still could do it, and they hadn't really broken this threshold. So there was a lot of controversy and people were upset about it. But in any case, that kind of brings us to today, where Google has now put in some big new moves and has made some big new changes to quantum computing that may actually be tipping the scales and giving them the official title of quantum supremacy. So let's jump into it. I think what's really important here is the fact that Google recently reported a significant breakthrough with all of this. And simply put, this means that their quantum computer can now solve problems much faster than even their previous one. According to Google, their newest iterations of the Sycamore quantum processor, which is, it has an impressive 70 qubits, right? So remember the last one was just over 50. Now they have 70 qubits. And it can make calculations in an instant that would take the fastest classical computer nearly half a century to execute, 50 years. But in order to understand what is actually happening here, I want to talk a little bit about quantum mechanics. So essentially the backbone of quantum computing is quantum mechanics, which is a branch of physics that deals with a phenomenon on a minuscule scale. So the power of quantum computers stems from their use of quantum bits, a qubit, which unlike classical bits that can be either 0 or 1, can exist in both states simultaneously due to a property known as superposition. So Google's latest 70 qubit quantum computer has a vastly increased computational power compared to classical computers. To illustrate the calculations, it took Google's previous 53 qubit quantum computer a matter of seconds to process. That would take almost half a century for even the world's fastest classical computer, which is the Frontier in Tennessee. So, as it is often the case with groundbreaking tech, skepticism persists. Of course, critics are all over the place, and there's some recently at one of them is Sebastian White from the University of Sussex Ion Quantum Technology Group. And he argued that while these advances in quantum computing are academically impressive, they haven't actually demonstrated any practical real-world application yet. So also simultaneously, you got the people over at IBM who previously criticized Google, like we talked about, right? They said it's still possible for a computer to do this calculation, even if you're doing it in, what would normally take 10,000 years, you're doing it much faster. But there are some people on the other side. Cambridge-based quantum company Riverlane CEO Steve Brierley, he said that Google's achievements are a quote-unquote major milestone, claiming the debate over quantum supremacy is now resolved. So I think essentially as we kind of stand on the cusp of a potential quantum revolution, you could say, I think what's really important is talking about what the impacts of quantum computers are, and especially, in my opinion, with the rise of AI that we're seeing right now, what the impacts are as we merge this with AI, as we see a world where computers are, 10,000 years faster, and they're merged with AI. Like, what are the implications here? So that's kind of what I want to talk about on the podcast. One area that I believe I've kind of identified 10 areas I think would be that have big implications. One of them is drug discovery. So I think quantum computing can significantly speed up the drug discovery process by essentially it will be able to model molecule interactions at an unprecedented speed. So this could lead to breakthroughs in personalized medicine and the development of treatments for complex diseases like cancer and Alzheimer's. One can only hope. We've seen a lot of big progress there in AI. And so, you can only imagine the ways that a quantum computer that could get something done that would normally take 10,000 years in, 200 minutes or seconds or whatever, would be able to speed that up. Another area is financial modeling. So quantum computers could revolutionize financial modeling by essentially analyzing large, complex data sets and making predictions with really high accuracy. Previously, we may not have had the power to be able to do that, but with these faster computers, I think this could really transform risk management, investment strategies, and forecasting. Now, a caveat on this with financial modeling is the fact that who has the quantum computer? Google obviously has one. IBM obviously has one. We're going to see these massive, tech companies that are having these super powerful quantum computers. This is not something that your average citizen is going to have. So, well, I think, there's probably a lot of benefit in healthcare when you're just doing drug discovery, although even that can be disputed because some people complain that it's just big pharmaceutical companies that are going to be able to afford these things and maybe not smaller startups trying to come out. So, there's going to be that whole discussion. And perhaps they'll do price gouging and all sorts of other things pharmaceutical companies have been accused of. So there's that aspect. But I think that it's definitely going to be prevalent in the financial markets where you have these massive hedge funds, perhaps massive tech companies that may be able to do this financial modeling, may be able to get these really complex formulas, and they're obviously just going to completely outpace real regular investors, your average person. Now, this is not really surprising. I believe that BlackRock, for example, has their Aladdin model, which is an AI model that can help them make some pretty massive predictions. And I believe that a lot of these hedge funds already have a lot of these sophisticated tools. So this isn't necessarily anything new, but taking this to a whole new level with quantum computers may just kind of increase that quote unquote unfair advantage, as it were, of helping these massive firms get more wealthy. The other area that I think actually has some interesting implications is traffic optimization. So in congested cities, quantum computers, I think, might actually be very powerful and useful for optimizing traffic flow in real time by processing massive amounts of data from GPS systems, sensors, satellite images. I think this is going to lead to a lot less congestion, reduced emissions, and more efficient transportation systems. Now, the thing about this is already being done to a degree. If you've ever used Google Maps to get somewhere, you'll know that sometimes they say, hey, fastest route is actually to get off the freeway. This happened to me in LA. It was like, hey, fastest way to get where you're going, which normally you just drive straight down the freeway, get off the freeway, take the side street, pull back on. And I was like, okay. So I hop off, and all of a sudden, tons of people are hopping off the freeway with me, going down this random side street. It got super congested on the side street. Eventually, we went down a few blocks, then we pulled back onto the freeway. And I was like, that is strange. But I think what Google was doing was saying, we're trying to get the fastest way to get this massive amount of cars from point A to point B. We can see where everyone's going because they're all on Google Maps with their GPS. So if we route a couple people off to the side to these side streets, we can reduce traffic on the main freeway, and those side streets we're using up more roads, so perhaps we'll get everyone there faster. I think that's Google's concept. So they are kind of doing this in real time at the moment. Some people argue that it's going to be hard for like a city or the government to get access to all of this data. And I think that's true, but I think that it's going to be done by private companies like Google, who already have access to all of this data. They're on everyone's GPS. Apple Maps, maybe another competitor in this space that has all of this data that's going to be able to do this. And so now the question becomes, we're already doing this to a large scale with, evidently very powerful computers and processors, but what happens when there's quantum computers that can do that's, calculations 10,000 times faster? What changes will that be able to make? So I think that is an interesting area. One other area that I think is going to be pretty powerful is supply chain optimization. Quantum algorithms can solve really complex optimization problems, and I believe that will apply to supply chain. I think this is actually going to be able to help businesses minimize costs, reduce delivery times, and perhaps improve overall efficiency. One area that, of course, is very evident, especially with AI today, is quantum machine learning. So combining kind of quantum computing and AI, I think could create powerful machine learning systems. Quantum machine learning could analyze vast data sets, lending to more accurate insights and predictions across numerous sectors: healthcare, finance, energy, a lot of things we've talked about. But I think quantum machine learning is going to be big. And the reason why I think this is because if you think about it, recent leaks came out where essentially the cost and model weights and a bunch of other things from GPT-4 were leaked, and it was essentially they reverse engineered it and realized it took about $63 million to train GPT-4. That was OpenAI's cost on, compute costs based off of what it looks like they were doing. And it also took them 3 months. So imagine a world with a quantum computer where a GPT-4, and I'm not sure if what the cost changes would be, like electrical consumption and whatnot, but I have to assume it would be lower if these machines are running for less time. But regardless about the cost, if the speed of training ChatGPT went from 3 months to, 3 minutes, that is some significant improvements. And all of a sudden, if, OpenAI or any other company wanted to iterate on AI models faster and faster, this is going to make a major difference. I'm curious to see how NVIDIA plays into this if they start making components for supercomputers, because evidently if this becomes mainstream or, if Google starts licensing out this tech, people are going to want to get their hands on these quantum computers in AI. And so obviously we see this massive AI gold rush with GPUs and other different chips and devices. NVIDIA's, their market cap got pushed to over $1 trillion because they're one of the number one suppliers of the tech behind training these AI models, the NVIDIA H100s and whatnot. But imagine if NVIDIA doesn't take advantage of this, somebody else will, and they're going to be making some very, very hefty profits, potentially Google, right? It seems like they're really leading the way, potentially IBM or some other companies. But, with the way that NVIDIA's stock price got pushed to the moon recently, you got to imagine that there's a lot of other companies that are really looking at this space, especially in quantum computing, realizing this could be their big break to push their companies past the $1 trillion market cap if they really can get this quantum computing technology mainstream, even if not for regular consumers, but just for, these AI companies training. So I think that's going to be a really big area. One thing I did want to touch on is encryption and cybersecurity. So quantum computing, it can both threaten and enhance cybersecurity. I think really the key is threaten at this point, because essentially it can crack traditional encryption methods. Now some say, like, if they're trying to put a positive spin on it, they could lead to the development of new, more secure quantum encryption techniques that will be virtually unbreakable. But it's a little bit hazy how those methods will be built, and they haven't been built yet. But what we do know is it definitely can crack encryption. It's typical encryption for a quantum computer, no problem. I also wonder what the impact of that is going to be if they set a quantum computer loose on, for example, the Bitcoin blockchain and had it, try to mine up all the Bitcoins in a matter of, minutes or something crazy like that. There's definitely is a lot of interesting implications there as well. One other area is in artificial intelligence research. I think quantum computing will really accelerate AI research by handling complex computations at high speeds. I think it's going to help in building more advanced AI models and understanding AI decision-making processes better. And then some people have actually said that they believe it's going to help with astronomy and physics. So in scientific research, quantum computing theoretically could revolutionize the way we simulate and understand the universe. It could help astrophysicists make sense of massive data sets, leading to potentially breakthroughs in our understanding of dark matter, black holes, and some other cosmic phenomenons. So overall, I think that there are some massive implications for AI, especially as we're mixing this with quantum computing. And I'm very curious to follow this into the future, because inevitably this is kind of the next step in AI's journey. is these supercomputers that are going to take it to the next level and be able to build these models, thousands and thousands of times faster and hopefully less expensive. So it's going to be very interesting to see how that plays out in the future. If you are looking for an innovative and creative community of people using ChatGPT, you need to join our ChatGPT creators community. I'll drop a link in the description to this podcast. We'd love to see you there, where we share tips and tricks of what is working in ChatGPT. It's a lot easier than a podcast, as you can see screenshots, you can share and comment on things that are currently working. So if this sounds interesting to you, check out the link in the comment. We'd love to have you in the community. Thank you for tuning in to the AI Applied podcast. Make sure to rate this wherever you listen to your podcasts and have a fantastic rest of your day.